All right, in 2.1, we focus on the advantages and disadvantages of using one equation rather than two or more equations to represent a given situation. So in the very beginning here, we're going to talk about these two questions. Is 10x plus 2x equal to 9x plus 3? And is 3a plus 3b equal to 6ab? So you're going to take a few minutes and explain that with your team, and then we will go over this together. So go ahead and pause the video at this time. Okay, so now we come back together. Let's see what you've come up with for the first one. Is 10x plus 2x equal to 9x plus 3? Well, you do have like terms on the left side, but you do not have like terms on the right side. 9x plus 3 are not like terms. You cannot combine them. So the answer is no, they are not equal to each other. In the second question, 3a and 3b are two different variables. And again, you cannot combine two different variables. It is like combining fractions with uncommon denominators. You cannot do that. So B is also a no because those are not like terms. So moving in now to the meat of the lesson, we're going to come up to the first challenge of writing an equation. And you're going to see three students here that are doing a walkathon. And what we're going to do is you're going to search for equations for those three students with the information over here to the left. Leanne, Gilberto, and Alana. So Leanne has 16 sponsors, and each of those sponsors are giving her $10 a piece. Gilberto has 7 sponsors, and each sponsor is giving him $2 per kilometer that he walks. And then Alana has got 11 sponsors, and each sponsor for her is giving her $5 flat fee plus 50 cents per kilometer. So you're going to take a few minutes here and go over and see what you can come up with for these equations, and then we will kind of team up and go over them together. So in part A, you're going to answer questions 1 and 2. So go ahead and pause the video. All right, now that you've had a chance to go through that, let's talk about Leanne first. Well, if Leanne has 16 sponsors and each one gives her $10, you could have come up with 16 times 10 as her equation, or $160. Because again, it doesn't matter how far she walks. She's only getting $10 from each person. They didn't pledge her per kilometer or anything like that, so she basically gets a straight flat pledge, which basically means if you were to graph her walk, it's going to be a horizontal line. It's never going to increase. Gilberto has $2 per kilometer for each person, so you could have had 7 times 2x, or you could have multiplied them together to get 14x. Either expression is correct. So that's going to be his total money that he would collect. So if he walks 5 kilometers, you would take 14 times 5. All right, and then Alana had 11 people, and again, the reason it's written as an expression because she's going to get 50 cents per kilometer plus $5 from everybody. So again, that x will be the number of kilometers that she walks. So if we were to find an equation for the total money of all 3 people in their team, all we're going to do is take these 3 expressions and just combine them by adding them together like so. So you can have them as what we have written here, or you could write just 160 plus 14x equals 5.5x plus 55. So either way is correct, but again, you're just going to combine all 3 people together to get the team dollar amount total. So in part B, it asks us to write an equivalent expression. And when we write an equivalent expression, we can pretty much just simplify it by multiplying 16 times 10, 7 times 2x, and distributing the 11 into this expression here, which would give us that. All right, once we come up with this, 160 plus 14x plus 550x plus 55, we could also then take that and simplify it by combining like terms. So you could have come up with those 2 possible answers as your equivalent expressions to number 2, part A. So down here in part C, is this relationship between the kilometers walked and the total money raised linear or nonlinear? Well, when you're talking about money, well, that's what's equal to. Money is dependent upon how far you walk, except for obviously Leanne, right? because Leanna, she got a flat pledge. But when you combine this all together, where the equation right here, where it says the 1950x plus 215, the total of their group depends upon how far the team walks. Because Gilberto and Alana have per kilometer pledges. So the more kilometers the team walks, the more money they will earn. So down here, your answer is linear. Because again, when also, if you take a look at your equation, 19.5x plus 215 is also in y equals mx plus b form. And that $19.50 per kilometer is your constant rate of change. But it also has an independent and dependent variable, which money depends upon the distance that you walked, number of kilometers. So this is a linear model. Heading over to the back sheet, the back side of it, we talk about ways that we can simplify expressions and how we know they're equivalent. Well, we can always simplify them, and we can simplify them by using lots of different methods, the distributive property, commutative property, and also combining like terms. Okay, so what I want you to do is below here it says pick one of your expressions to find the total amount the team will raise. Use the expression to find the total amounts if the students walk 5 kilometers and if they walk 8 kilometers. So going back to the front side here, we wrote this equation or you wrote this equation. So you're going to pick one of those two, or actually I should say one of those three, and you can go ahead and solve it. Now more than likely the easier one is going to be to use this one because it's the shorter of all the equations. Okay, and then of course we're going to solve it for if they walk 5 kilometers and 8. So we're going to go over here to the board and we will go ahead and solve this. All right, so if we solve this for 5 kilometers using the equation, okay, plug in the 5 for kilometers walked. 19.5 times 5 is 97.5, and then we're going to add 215 to it. And then when I combine those together, 97.5 added 215, we get, this is going to be a dollar amount, so we're going to add a 0 in here, $312.50. So if the team walked 5 kilometers, that's how much money they will make as a group. If they walk 8, that means they're going to make more money. We're going to plug the 8 in for x now. So 19.5 times 8 is 156. And when I add 156 to 215, we get $371. So this is the amount of money the team would make if they walked 8 kilometers. Okay, so it's just taking those variables and plugging them into the equation and solving. So which expression did you use and why? Well, I picked the shorter one because it was more simple to use, less work. And that's usually probably going to be the case when you talk about using the equation. Obviously, use the simple one. Work smarter, not harder. So when we wrap this up here, what are the advantages and disadvantages to using one equation rather than 2 or more equations or expressions to present a situation? Well, the advantages obviously are it's much less work. There's less steps. There's less places to make a mistake. It's a simpler process. When you're using multiple equations to try to solve one scenario, which is what you'll find out in 2.2, it can get a little crazy. Now there's a disadvantages to using one equation also. Sometimes when you have more than one situation, it's hard to kind of see what parts are what. For example, when we did the gym with the cafeteria and the lobby, once we combined everything, it was hard to figure out which went where. So, there are disadvantages, but most of the time, the advantages do outweigh the disadvantages. So, the homework assignment for this section is right here. For those of you who didn't get it the first time, and we're going to stop the video.